Okay, these are two reversible reactions, and they're in the AQA specification, and they've been very two classic reactions to demonstrate that chemical reactions can sometimes go backwards. You probably remember one of the first things that you learn about chemical changes is how can you tell it's a chemical change? You can't undo it. You can't make it go backwards. Like you burn a piece of paper, you can't unburn it. But some chemical reactions can go backwards, and here's a couple of examples. Right, now the first one is copper sulfate. Now this formula probably looks unfamiliar to you. CuSO4.5H2O. Right, now when you have your familiar blue crystals of copper sulfate, they've actually got water molecules, not just trapped in there, but chemically bonded to the ions. Okay, so it's very specific. The number you have 5 H2O molecules for every 1 copper ion, 1 of sulfate ion. Right. So that the chemical there is, and this is sometimes called hydrated copper sulfate. Okay. Now, if you heat it up, you'll turn it into. So, I've got some pictures here. So you heat in the blue copper sulfate. This is the hydrated stuff there. You heat it up. You drive off some water. Okay. So you drive off the water. So that's why you see the sort of steam coming out the top of the tube here, and you sometimes see on the side of the tube there a little bit of condensation forming water. And by the time you've finished the reaction, you end up with, it's no longer blue, you've got a white powder there. And that white powder is sometimes called, well, it is called anhydrous copper sulfate. Now this reaction is endothermic. You need to provide, it takes in heat energy. Converts, if you like, converts energy from the thermal store into the chemical store. Okay, so it's endothermic. Now you can easily reverse this reaction. So if you let this test tube here, if you've done this experiment, you just let it cool down. And then you add a little bit of water to it. So the test tube is cool. You add a few drops of water there, and the crystals will turn blue. And if you touch the bottom of the test tube there, you will feel that it gets very hot. It's almost like enough to burn your fingers. It's a very exothermic reaction. And that's kind of stands to reason. You think about the conservation of energy. Look, if you go this way, copper sulfate, the hydrated stuff, that's got to be exothermic. That's endothermic. And you form copper sulfate anhydrous, the white powder, and water vapor. Right, if you add the water back, that's got to be exothermic. But you can't, if it wasn't, then you could like sort of create energy by going round and round in circles, which obviously you couldn't do. So it's endothermic in one direction and exothermic in the other direction. The other example that they want you to know about is this one, ammonium chloride. Okay, now ammonium chloride has got that formula, and it's a white solid. It's an ionic solid, so it's got a high melting point. But if you heat it up, it will decompose into ammonia gas and HCl, hydrogen chloride gas. Now we don't call it hydrochloric acid. We only call it hydrochloric acid when it's dissolved in water. It's covalent. It's a hydrogen chloride gas, and that is pretty endothermic. Okay, you've got to provide energy for that, heat energy, and the heat energy gets converted to chemical energy. So if you do that, here we've got some ammonium chloride in the tube there. You heat it up and it decomposes. And then you notice at the top of the tube, you're getting a white solid forming here. And the reason for that is what happens is when it gets cooler, the NH3, the ammonia gas, and the HCl gas will recombine to form ammonium chloride solid. and that is exothermic. And that can occur higher up the tube because it's a bit cooler up the tube, yeah. That's the top of the tube, and it will reform there. So there's two examples of reversible chemical reactions which can be reversed. And the thing they really want you to take in there is if it's endothermic in one direction, it must be exo in the other direction. And this is like a little bit of an introduction to the equilibria topic.